Okay, so we've got this problem, and we're asked to find the area of this triangle, EFG. So that's EFG. So that's the big triangle. So the area of any triangle is going to come down to the base of the triangle times the height divided by 2. So the base of the triangle is going to be this one here from F to E, FE. But it's kind of difficult because we don't know FE. We'd have to know what the distance from F to H is in order to get that. So let's have to put a pin on this and come back to it. So we need to figure out what FH is. So let's take a look at this triangle here as if it was its own problem for a minute, from FHG. Let's just look at that problem on its own. So here we have FHG. So in my mind, I just see a right triangle with a missing side, same as we've been doing. So why don't we use the Pythagorean theorem? So we have a squared plus b squared equals c squared. And it'll work because it's a right triangle. Let's say this is my a square, or my a side. So let's plug that in, 7. We don't know the b, so we'll say b squared equals, and we know the c, we know the hypotenuse. So that's 10. So then we can start to simplify. So 7 to the second power is 49, plus b squared equals 10 to the second power is 100. So then we'd subtract 49 from both sides, and we get b squared equals 51. So if I take the square root of both sides, I have to use a calculator for this, but once I put it in the calculator, the square root of b squared is b, and the square root of 51 is 7.14. So now we can put that in up here. So that's 7.14. So that's 7.14. So if I add these together, FH plus HE, that's 7.14 plus 3 gives me 10.14. So now I can plug that in for the base of my triangle. So we can say the area equals 10.14 times the height, which is 7, right there, all divided by 2. So I put that in my calculator, and I get 71.4 divided by 2 is going to equal the area. So I simplify this. I divide 71.4 divided by 2, and we get 35.8 units squared.